Good day, ladies and gentlemen. I hope you are still well. Welcome back to another session of Newton's second law of motion. And then today we'll be looking at an exam type of question, as you can see there. And for reference purposes, this problem now comes from the question paper from the Free State Department of Education, March 2024. It was written yesterday in the Free State. It's a very interesting problem. It talks about now this second law of motion, and I would like us now to see the approach to this kind of a problem. Let's without any waste of time have a look and see what does this problem have in store for us. Now it says the two blocks 10 kg and 15 kg are attached to each other with a light inextensible string. Ladies and gentlemen, we have talked about this. An inextensible string just tells me that the tension here will be now the same with that tension there. And then moving over a frictionless pulley as shown below. This moving here, ladies and gentlemen, it talks about the string. The string is the one that is moving over the pulley, over the frictionless pulley, as shown below. Slope AB, slope here is A, here is B, has a smooth surface, meaning that this surface of ours is smooth. It does not have any friction there. And then it says to us, it makes an angle of theta with the horizontal. And then here, ladies and gentlemen, that is our diagram there. And then I know that you'll agree that before trying to attempt these questions here, let me bring this closer. Before attempting to answer these questions here, ladies and gentlemen, you'll agree with me that we agreed that we have to now say, let's draw a free body diagram. Let's draw a free body diagram for these blocks of ours, for these two blocks of ours here. And then with doing that, you'll see now I have two blocks. I have now the 10 kg. Then I will say for the 10 kg, I have to now draw a free body diagram for the 10 kg block. And then when I look at the 10 kg, look at this, ladies and gentlemen, you will encounter blocks or objects that are now hanging. When an object is hanging like this, there's only now two forces acting on that object. The first force that is acting on this object is the force that is now keeping this 10 kg hanging in the air like that. And then you'll agree with me that the force that is keeping that object up there will now be the tension. The tension is the one that is holding this 10 kg in the air like that. And then because this 10 kg block of ours has mass, and then it says to us that there must be now the gravitational force Fg like that. So we are saying whenever we encounter an object that is hanging like that, we say now this object of ours is going to have two forces. It's going to be the tension force that is keeping the object up, and also now the Fg. And then I think we'll be done with the 10 kg. And then if we go now to the for the 15 kg block, we see now that this 15 kg of ours, ladies and gentlemen, is acting now on an inclined plane. It's acting on an inclined plane. And then previously we agreed that when we have an object on an incline, we'll then draw an inclined plane like that. We'll draw an inclined plane like that, and then I'll still have my dot there to represent the 15 kg block. And then this 15 kg block, it's connected by S3. This tension of ours this side is going up, so this tension of ours on this block must now go up the incline there, like that. We'll have to go up the incline like that, and then I will have my tension force. Because now, what is it that is keeping this 15 kg from going downwards? It's this tension force that is holding it back like that. And then remember the free body diagram that I'm drawing here. I'm drawing the free body diagram with components, the one that is going to help me with the calculation. So if I draw that free body diagram, I can see that the object is on the surface, and then if it's on the surface, it must have a normal force there. And then we said, when I draw the components, those components are going to be the components of weight. And then if I draw the components, I have two components which are now FG perpendicular, and then I will then here draw my FG parallel. So these two are my components of weight. And then we talked about something in the previous video, that whenever I have a block that is on an inclined plane, or an object on an inclined plane, what is it that I must remember always? I must now remember the following analogy. I must remember pass, peg. Now, this pass peg of mine, it helps me now to remember about now these two components there. That the parallel component, meaning this one, it's sine, and then the perpendicular component, it's cos there. So what it simply says, it's that now the parallel component FG parallel is equals to FG sine of theta there, parallel sine. And then perpendicular, it says to me FG perpendicular is equals to FG cos of theta there. So this perspective of mine helps me now to understand now, or to remember now, these two components. And then with that, with those free body diagrams, and then it says to me, I can now go and look at my question. So here is the question, ladies and gentlemen. The question says now, before the question, it says both blocks are stationary. Both blocks are stationary, meaning that these two blocks, they are not moving. These two blocks are not moving. Let's get to the first question and see there. It says now, state Newton's first law of motion in weight. And then I know you know how to state Newton's first law in weight. You just have to go to your examination guideline, and then it says now an object will remain in its state of rest or motion at constant velocity unless acted upon unbalanced air forces. Let's write it down real quick. It says to us there, a body will remain in its state of rest or motion at constant velocity unless acted upon unbalanced forces. So this is now me stating now Newton's first law of motion in words there. I know you know this, you just have to get it from your examination guideline. And then let's get to the real problem now. The real problem says now, let me get this close. The real problem says draw a free body diagram showing all the forces acting on the 15 kg block. Now, ladies and gentlemen, this is what I was talking about. The examiner just asked me to draw a free body diagram. The examiner just asked me to draw a free body diagram for the what? For the 15 kg block. So if the examiner asks me to draw a free body diagram, I know you'll agree with me that the free body diagram that we are going to draw, it's a free body diagram without components. A free body diagram without components. Remember, I will still have my normal force there. This is the surface. And then here on this side, it's now going to be the tension, and then because this object is now having now a force that is pulling it downwards like that, which is Fg. Fg will now be like that, ladies and gentlemen. So if the examiner asks me to draw a free body diagram, this is the free body diagram that I draw. The free body diagram without components. This one is the free body diagram with components, and then this one is the free body diagram without components, because the examiner has asked me to draw a free body diagram. This is the free body diagram that I draw, ladies and gentlemen. I hope you are all well with that. And then the last question there says to us, calculate the angle theta there. Interesting. We want now to find angle theta there. And ladies and gentlemen, for us to find angle theta there, we need to apply Newton's second law of motion, or we need to apply physics principles to find that theta there. And then for me to apply those physics principles, it says to me, I'm having two objects there, and then the other one is the one that is hanging, which is the 10 kg and the 15 kg. And then it says to me, let me go now and find F net for the 10 kg. And then after finding the F net, I will then find the tension. After finding the tension, I will then substitute it here. And then I will find now Fg parallel, because I know Fg parallel has that theta there. So that will now be the approach. The approach will now be saying, let's find F net is equals to MA for what? For 10 kg. Let me find first F net for the 10 kg. Now the choice of direction is yours. You can choose up to be positive, and then you can choose now down to be negative there. So if you do it like that, up if it's positive, it means now on this other 15 kg block, down will be negative, and then up will now be positive like that. Because remember, we said the tensions must get opposite signs there. So if this tension here is positive, this one here has to be negative, meaning that the downward motion of this 15 kg block will be positive. So if upwards is positive, it then says to me tension minus Fg is equals to Ma. And then I know that tension is equals to Fg. Fg is the weight. It's Mg is equals to Ma. Can I now substitute? Yes, I can. So if I substitute there, it's now going to be tension. Remember, I'm looking for the tension. It's going to be 10 multiplied by 9,8 is equals to MA 10. And then remember, they said the blocks are stationary, so it means they are not moving there, so acceleration will be 0 there. So it's now going to be the tension minus 10 multiplied by 9,8, it's 98, is equals to 0 there. And then it says to me, let me transpose. It's going to be tension is equals to 98 newtons. 98 newtons there. And then if this tension is 98 newtons, ladies and gentlemen, you know that the string is inextensible. So if this tension here it's 98, it also says to me that this tension here it's also 98. So with that being said, I now know the tension here. Can I use this tension here, substitute it here, and then be able to find a theta there? How will I do that? I will then say for 15 kg, F net is equals to MA. I'm applying now Newton's second law of motion to each block. For this 10 kg, I used now this Newton's second law of motion to find the tension there. And then I will use this tension to be able to find my theta there. And then remember our signs. We said if this tension here it's positive, this tension on the other side has to be negative. So it's going to be negative tension, it's here, and then plus FG parallel is equals to MA. But remember, we said we're starting with the positive ones, so it's still not a problem. We can write it as a FG parallel minus tension is equals to MA. And then I know that my FG parallel, we said FG parallel is equals to FG sine of theta minus tension is equals to MA. I hope you can see that, ladies and gentlemen. So let me use the red color here because the black one is now or let me rather use the blue one here. So FG, we know that FG is equals to mg sine of theta minus the tension is equals to MA. What is my mg? I know my m it's 15 multiplied by 9,8 sine of theta there. Ladies and gentlemen, this theta here, this theta there, it's the one that I'm looking for. So it's going to be minus the tension. Tension, we said it's 98. So it's going to be 98 is equals to mass 15 multiplied by, both the blocks are not moving. So if it is 0 here, it says now also here has to be 0 there. And then I will then take my calculator to say 15 multiplied by 9,8 and then it's 147 sine of theta. Then can I transpose this negative 98 to the other side? So yes, it's going to be 98 there. And then here, when you are here, ladies and gentlemen, you just have to perform your mathematics. I will then divide by 147 both sides. So this one cancels there, and then I will be left with sine of theta is equals to 98 over 147. And then I know when you get here, it's just simple mathematics. You will then take the arc sine. You will say now arc sine of 98 over 147. 98 over 147 is equals to theta. It's equals to arc sine there of 98 over 147. And then out of space there, let me just write the value of theta here to say theta will be equals to 41,81 degrees. So that will now be your value of theta there. And then this was just an interesting problem of now 10 marks there. 3 marks for the free body diagram, 5 marks for calculating the angle of theta, 2 marks for stating Newton's second law of motion. Thank you very much, ladies and gentlemen. I hope now you enjoyed the lesson. Please don't stop subscribing, like our videos, and share with your friends. There's more physical science content that is coming to you now. And then after some while now, we'll be now looking at electrostatics. I hope you enjoyed your lesson, ladies and gentlemen. Thank you very much.